Hi grade 12s and welcome, and in this video we'll be looking at the 2020 Science GCE paper 1, and this is the Examination Council of Zambia, Examination for General Certificate of Education, Ordinary Level, Science paper 1, 2020, and there we have the subject code, which is 5124/1. So this is science paper 1, and for this paper you are given 2 hours and it carries about 85 marks, and you need an electronic calculator. You'd be allowed to have a calculator with you, a graph paper, a soft clean eraser, a pencil, and yeah. So we can get to working out and dealing with this paper. So in this video we will look at questions 1 to 20, that is section A only. So here we do have our first question, question A, section A, which carries about 20 marks, and question 1 says, A1 says, how many significant figures are there in the number 0.050200? How many significant figures are there in the number 0.050200? So firstly, all non-zero numbers are significant. So if a number is not 0, then it is significant. So numbers from 1 to 9 are significant. And when we are dealing with zeros are significant only if they meet certain requirements. Okay, so not all zeros are significant figures, but only zeros that meet certain requirements would be considered as significant figures. So any number at the beginning, any zero at the beginning of a number is not significant. Any zero in between two non-zero numbers is significant. Any zero that is trailing a number is significant. So the last zeros in any given number are significant. Any zeros in between numbers is significant. And any zeros at the beginning of a number are not significant. So how many significant figures are there in the number 0.50200? So as I stated earlier, all non-zero numbers are significant. So we have 1 and 2, and we have a bunch of zeros there. And which zeros are significant? Zeros that are in between numbers, in between non-zero numbers. So this one is significant, so that makes it 3. And any zeros that are trailing, that are at the end of a number, are significant. So we've got 1, 2. And zeros that are at the beginning of a number or of a figure are not significant. So these two are not significant figures. So we have 1, 2, 3, 4, 5. So we have 5 significant figures. So the correct answer there is C. We can move on to A2. A2 says, a stone of mass 400 grams is lowered into a measuring cylinder containing water. The water level rises from 300 centimeter cubed to 500 centimeters cubed. What is the density of the stone? A stone of mass 400 grams is lowered into a measuring cylinder containing water. The water levels rise from 300 centimeters cubic to 500 centimeters cubic. What is the density of the stone? So density equals mass over volume, right? What is the mass? The given mass is, we're given the mass right there, and the given mass is 400 grams. So we have 400 grams, right? And what volume do we have? Well, the volume of the stone can be found by subtracting the volume of the stone and the water by subtracting the volume of the water from the volume of the stone and the water. So this 300 centimeter cubed is the volume of the water alone, And the 500 centimeters cubed is the volume of the water and the stone together. So the volume that we have is simply 500 minus 300, which gives us 200 centimeters cubic, right? So we have density equals to that. So mass 400 over, so this is grams, over 200 centimeters cubic. And this gives us, the zeros leave, 2 into 4 gives us 2. So 2.00 grams per centimeter cubic, which is D. We can move on to A3. A3 says the graph below shows the speed of an athlete during a race. The graph below shows the speed of an athlete during a race. So we have speed, which is in meters per second. We have time, which is in seconds. What is the distance traveled by the athlete? So grade 12s, you should know that speed equals to distance over time, right? So to find distance, we'd have to say distance equals to speed multiplied by time. All right? So the question is asking us to find the distance traveled by the athlete. So we have speed and we have time down there. So whenever you have a graphical representation or a speed time graph, to find the distance, all you have to do is find the area that you have on, or the area of the shape that is formed on that speed time graph. So to find this area, we can simply cut this shape that we have into different and easily solvable shapes. So we can have a triangle right there. You see that triangle? We can have a triangle right there. And this triangle has a base of 4 and a height of 5. It has a base of 4 seconds and a height of 5. So to find this area, I would simply say area of a triangle equals, so let's say area 1 equals, so area of a triangle equals half, remember that, BH. And this is equal to half, what is our base? 4 seconds, or yeah, 4, let's just say 4. What is our height? Our height is 5 meters per second, so we'll have 5 there. And 4 multiplied by 5 gives us 20. 20 multiplied by half gives us 10. So our first area is 10. And this is not just 10, but since we're finding the distance, this is 10 meters. Our second area is this shape that we have there. This shape, which is a rectangle, so area 2 equals, how do you find the area of a rectangle? You simply say base multiplied by height. In this case, we'd have our base is from 4 to 16. So what is the value of our base or breadth? Would have 14 minus 4, which gives us 10. The distance from here to there is 10. So we have 10, these are brackets, multiplied by, what is our height? From there to there, it goes up to 5. So 10 multiplied by 5 gives us a 50. So we have 50 meters as our area 2. And our area 3, what shape do we have there? Well, so there are two ways in which you can do this. You can either cut this shape into two shapes by doing that, such that you have a rectangle there on top and you have a rectangle down there and a triangle down there on top. Or you can find the area of a trapezium. So to make things really easy and understandable, what we're going to do is we are just going to find the area of this triangle there and the area of the rectangle down there. So to find the area of the triangle, we're going to say what is our base there? is from 16 to 14, which is 2. So we'll have half 2 multiplied by what is our height from 5 to 10, which is 5. And this gives us 10 multiplied by half gives us 5 meters. And the one at the bottom there, we have a rectangle. So to find the area of the rectangle, we would say its base is from 14 to 16. So it simply has, so it's BH. So we'd have area 4 equal to, what is our base, which is 2, and our height, which is from 0 to 5, which is 5, right? And this gives us 2 by 5 gives us 10. So now to find the total distance covered, we'd have to add all our areas. So we are going to have area 1 plus area 2 plus area 3 plus area 4. So total distance D equals A1 plus A2 plus A3, A1 plus A2 plus A3 plus A4. So what is our area 1? Area 1 is 10 plus area 2 is 50, area 3 is 5, and area 4 is 10. And this gives us 75 meters. So therefore the correct answer for A3 is 75 meters, which is C. We can move on to question 4. Question 4 says, a 4-kilogram brick is dropped from the top of a building whose height is 30 meters. What is the velocity with which it hits the ground? A 4-kilogram brick is dropped from the top of a building whose height is 30 meters. What is the velocity with which it reaches the ground? So we are given the mass, we're given the height, we are asked to find the velocity, right? So do you remember this formula? Distance equals to UT plus half AT squared. And you should also be familiar with V squared equals U squared minus 2AS. Sorry, plus 2AS. Okay? So which one do you think we use? Do we use this one or we use that one? Well, I believe we use this one, looking at the information that we have been given. So looking at the information that we've been given, we have the distance, which is 30 meters. So we have distance, which is denoted by S, which is 30 meters. We have also been given, what else? So its initial velocity, it is starting from 0 because it's being dropped. And we also have the mass, which I believe isn't going to be so helpful. And what else do we have? We can find the acceleration, right? Can we find the acceleration? Yes, we can. Well, since it's falling from a building and it's falling due to gravity, it means its acceleration is equal to gravitational pull, which is 10 meters per second squared. Okay? So never forget this. Whenever you have a free-falling object, its gravity, its acceleration is always equal to gravity, which is 10 meter per second squared. So now we can use this formula, this equation that we have. So V squared, we're looking for V squared, we're looking for V actually, which is the final velocity. So V squared equals, what is our initial velocity? 0 plus 2, what is our acceleration? 10 multiplied by what is our distance? 30, and we have that. So V squared equal to 2 by 10 by 30 gives us 20 by 30, which is 600, right? And we can find the value of V by finding the square root, introducing the square root to both sides of the equation. So let me just get my calculator. So we are asked to find the square root of 600. So square root 600. And this gives us 24. So let's just write it here. So this is, let's move the calculator to this side. We have 24.49, 24.49, and this can be rounded off to 24.5, so 24.5. And since this is velocity, it has the units meters per second squared. Sorry, meters per second. I was thinking of acceleration there. So we have 24.5 meters per second, which is B. Can move on to question number A5. Question A5 says, the diagram below shows an object with a constant velocity when a force E of 30 newtons is applied. So we have a force E being applied there. It's moving this object in this direction, and we have a counter force, an opposing force, which is F, pushing it in the opposite direction. The question says, what is the value of the opposing force F? Well, if you're familiar with Newton's laws, you should know to say when an object is moving in, when an object, it says an object will remain in constant motion or will remain at rest if a constant force is applied to it. So if you have constant force being applied to a certain object, it will not accelerate. It will just remain at that velocity, to remain at a constant velocity. So if this object is moving at a constant velocity, it means that no force between the two is greater than the other one. Okay? It means that no force between these two is greater than the other one. So this force and that force are equal. So if this is 30 newtons, means this one is 30 newtons as well. So the correct answer there is C. Question A6. Question A6 says, a 60 newtons object is placed on a uniform bar that was balanced at its midpoint as shown in the diagram below. Which of the following will rebalance the beam? A 60 newtons object is placed on a uniform bar that was balanced at its midpoint as shown in the diagram below. Which of the following will rebalance the beam? So we have an object which is 60 newtons, which is placed 30 centimeters from the midpoint of the bar, and at that midpoint we also have a pivot. So this 60 newtons force will try to push this bar down, but for it to remain steady we should have another force that will push this bar clockwise. So this one will push it anti-clockwise. We need to have another force there. We need to have another object of a certain force which is going to push it down clockwise, such that this will push it in this way, and then this one will push it in that way. And if these two are equal, it means that it will be able to balance. So now what is the magnitude of this force, and what is the distance from the midpoint to this force? That is what we are asked to find. So if you are preparing for a grade 12 then I believe you should be familiar with the principle of moments. So a moment or moment is equal to force multiplied by distance. And if this bar will be in equilibrium, if this bar will balance, it means that the clockwise force, which is this one, must be equal to the anti-clockwise force. So the clockwise moment should be equal to the anti-clockwise moment. So meaning this moment should be equal to that moment. So moment 1 should be equal to moment 2. So force 1 multiplied by distance 1 should be equal to force 2 multiplied by distance 2. What do we have as force 1? Force 1 is 60 multiplied by 30, and this should be equal to force 2 multiplied by distance 2, right? So let's look at the options that we've been given. We have magnitude of 30 newtons at a position which is 60 centimeters to the left of the pivot, 60 centimeters to the left of the pivot to push it this side, meaning we're going to have another force here, which is 30 newtons, which is also going to be bringing this bar into an anti-clockwise position, and I really don't think that would give us balance in the beam. 30 newtons, 60 centimeters to the right, so 30 newtons, 60 centimeters to the right, so meaning somewhere here we have another 30 newtons, excuse me, which is pushing the bar down, causing a clockwise moment. Well, let's leave that answer, we'll come and review it. We have 45 centimeters, 45 newtons, 45 centimeters to the right, so 45 to the right. Okay, let's leave that one as well. D, 90 newtons, 20 centimeters to the left. So anything that is telling us to put the force to the left of the pivot is incorrect. So this option A and option D are out, and we are remaining with option B and option C. So we've said 60 by 30 should be equal to force 2 multiplied by distance 2, right? So let's just try to rewrite this equation with the options in A, in B, and in C, sorry. So we have 60, 30. In D, in C we have 45, 45. So we have 45, 45. No need to actually solve this. So this is option C. And for option B we have 60, 30 equal to 60, 30. This is option B. Now you tell me as grade 12s, which one do you think between these two options is equating the left hand side to the right hand side, has equal values on the left hand side and the right hand side? Well, to me, option B looks like the most probable one because we have 60, 30 on both sides of the equal sign. So our correct answer for question A6 is B. We can move on to question A7. Question A7 tells us to say, a motor is used to pull a 10 kilogram box along a 5 meter long incline to the top of the decline as shown in the diagram below. So we have an inclined, let's say plank, and we have a flat surface there, and we have a 5 meter distance from the bottom to there. We have a motor there, we have a distance of 4 meters there, and we have a box that is being pulled up. So ignoring all frictional forces, determine the work done against gravity in pulling the box from the foot of the incline to the top of the decline. Take G being equal to 10 newtons per kilogram. So this is question 7. And we are asked to find the work done, right? So we know that work is equal to force by distance. Am I right? And what is the force that we have? The force that we have is simply, this is 10 kilograms. And to find force equals to mass by acceleration, which is equal to mass 10. Acceleration is, we're told to take G as 9. So as long as we're dealing with something that is affected by gravity, we take our acceleration to be 10 newtons per kilogram, so 10. So therefore the force that we have is 100 newtons. This is the force, so F equals to 100 newtons. Then which value do we take as our distance D? Is it 4? Is it 5? So whenever you are dealing with work, the distance that you take is this distance. You do not take the inclined distance, but you take this vertical distance, which is 4. So we will have, what is our force? 100 multiplied by, what is our distance? 4. And we will have 400 joules. So therefore the correct answer is C, 400 joules. Move on to question 8. A girl whose mass is 50 kilograms climbs a ladder of height 8 meters in 10 seconds. What is the power developed by the girl? A girl whose mass is 50 kilograms climbs a ladder of height 8 meters in 10 seconds. What is the power developed by the girl? So firstly, you need to know that power is simply equal to the energy that you've put in over the time, right? And energy is simply equal to the work done, which is force times the distance. So power equals energy over time, and energy is equal to work over, is simply equal to work. So we'd have power is equal to work over time, right? So firstly, we need to know that work that is being done there. So work equals force times distance. What is the force? The force is 50 by 10, right? And the distance is 8. So let's get our calculator. Remove it to the side. So 50 by 10 by 8, and this gives us 50 by 10 by 8 gives us 4,000. This is equal to 4,000. But you know that power is equal to work over time. So say, what is our work? 4,000. What is the time that we've been given? 10. So this 0 and that 0 cancel, and we would have 400 watts. And 400 watts is option B. So that is how we work around that question. And question 9 says, a machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 60 kilograms through a vertical distance of 1 meter. Find the efficiency of the machine. A machine with velocity ratio of 6 requires 800 joules of work to raise a load of 60 kilograms through a vertical distance of 1 meter. What is the velocity? What is the efficiency? Find the efficiency of the machine. So when we are dealing with efficiency in simple terms is equal to, let me use different symbols. So efficiency is equal to the work output over the work input. This is simply equal to the energy output over energy input, right? So what have we been given? We've been given the requirement. So it requires, when you hear the term requires, you simply know to say this is how much you need to put in. So this is the work input, which is the energy input. So we have energy input, which is EI being equal to 800 joules. So now what is the energy output? What is the work output? So we do know for a fact that work equals force by distance. we have the force. Force is equal to mass by acceleration. What is our mass? 60. What is our acceleration? If we notice to say there's a vertical distance, then our acceleration is simply 10, right? So 60 by 10 gives us 600, right? So the work is equal to 600 by the vertical distance, which is 1, which is simply 600. So the energy output is equal to 600 joules, right? So we have our energy output, which is 600, divided by our energy input, which is 800 joules. We get our calculator. We say 600 divided by 800 by 800, and that gives us 0.75. So our efficiency is 0.75, which is B. So that is how we deal with question number 9. Question 10 says, the diagram below shows the length of mercury threads at the ice and steam points. Too much. Okay. The diagram shows the length of mercury threads at the ice and steam points. So this is the ice point and this is the steam point. So when you talk of ice point, we are simply talking of 0 degrees Celsius. When we talk of steam point, we are talking of 100 degrees Celsius, right? And at the steam point, at the ice point, we have 5 millimeters. So 0 degrees Celsius to 5 millimeters. And at the steam point, we have 15 millimeters. So we have 15 millimeters. What will be the temperature? What will be the temperature if the length of the mercury thread is 25 millimeters? What will be the temperature if the length of the thread is 25 millimeters? So we know that at the ice point we have 0 degrees Celsius, which is at 5 millimeters, and 100 degrees Celsius, which is at 15. So firstly, what we are going to do is we find the differences. So we'll say 100 minus 0 gives us 100. So for every 100 degrees Celsius, we have 15 minus 5 gives us 10 millimeters. So what if we are looking for 1 millimeter? What is the temperature change for every 1 millimeter that the thread has moved? So we cross multiply, would have 10x equal to 100 degrees Celsius. And we divide both sides by 10. By 10 would have, for every 1 degree Celsius, for every 1 millimeter moved, we would have 10 degrees Celsius. Okay? For every 1 millimeter, we have 10 degrees Celsius. So what if we have 25 millimeters? So 25 millimeters by 10 degrees Celsius, and that gives us 250 degrees Celsius. So according to the options that we've been given, 250 degrees Celsius wasn't there, and therefore for this question we had an error. So we can move on to question number 11. So we're on question A11. A11 says, the diagram below shows a cylinder with a gas trapped inside at a constant temperature. The length of the gas column is 50 centimeters and the pressure of the gas is 20 pascals. And we have there a photo of the gas column. We have the gas in there and we have a piston that's pushing down the gas. And the distance from the bottom of the column to the piston is 50 centimeters. If the piston is pushed a distance of 30 centimeters inside, what is the new pressure of the gas? If the piston is pushed a distance of 30 centimeters inside, what is the new pressure of the gas? So what we have is the piston is at 50 centimeters up there. And what happens if we push it 30 centimeters inside? So from here, we push it 30 centimeters inside. So this is where we're going to have the piston then, right? So the piston has moved there. This is 30 centimeters. Then what is the distance from here to where the piston is? This point we are going to have a distance of 20 centimeters. Am I right? 20 centimeters. So firstly, grade 12s, do you think the pressure will increase or the pressure will decrease? So you have the same amount of gas in there. None of it has escaped. But now you have less area, right? You have less area. So you should know that when you have less area, less volume, less area of substance being occupied, you would have more pressure. Think of a tire pump or a football pump. When you have a lot of air in there, or when the pump is, when you're just starting, when the pump is at the top, you'd need less force to push it down. But as you go down, you'd need greater force because there's a lot of pressure at the bottom there. So simply put, we expect the pressure to increase as we decrease the area of the gas, the area that the gas is occupying. So firstly, we know that at 50 centimeters, we have a pressure of 20 pascals, right? What if we have 20 centimeters? What will be the pressure that we'll have? So we can, so because we're expecting this to increase, as this decreases, what we're going to do is we're going to multiply this 50 by 20 and this 20 by x. So we're going to have 50 centimeters multiplied by 20 pascals equals 20 centimeter multiplied by x. All right. And here we're going to have, or we can divide both sides by 20 centimeters. Divide this side by 20 centimeters as well. And this centimeter and that centimeter would go. This and that would go. This and that would go. And the 20 and that 20 would go. And you'd have x being equal to 50 pascals. So therefore the pressure will be 50 pascals, which has increased. We have decreased the area, so the pressure should increase as it has. A12, for question A12, question A12 says, which of the following correctly gives the properties of a sound wave? So sound waves are longitudinal, transverse, which one? Longitudinal. And longitudinal waves have a speed which is 3.8 by 10 to the power 8, or 340. So longitudinal waves have a speed of 340 meters per second. So sound is a longitudinal wave with 340 meters per second. Question R13 says, the diagram below shows the movement of a ray from air to plastic. Which ratio is a refractive index? So we have that, it bends to that, we have that angle, and we have that angle. So to find the refractive index, let's denote it as Ri. Refractive index is equal to sine let's call that angle I over sine R. The angle of incidence there, the refractive angle there. So refractive index is equal to sine of incidence over sine of refraction. So which is the sine I? Sine I is the one on top there. We have sine 45 degrees over sine refractive angle is this one, not this one. So we take the angles from this vertical line that we have. That's why we've taken 45, and now we take 30. So sine 30 degrees. So according to the options we've been given, we don't have to go any further and start solving and looking for the answer. All we have to do is look for that, and we would have I don't know how I wasn't able to see option B. Would have B there. B is exactly the same as what we have found. And we can move on to question number 14. Question 14 says the diagram below shows the main sections of the electromagnetic spectrum in order of increasing frequency. We've got radio waves, we've got dash, Q, light, dash, dash, gamma rays. So the question is not asking us to identify anything. It's actually just asking us to find the application, or to tell or to name the application of Q. So what is Q? Q is simply infrared. And what is the use of infrared? Infrared is used in television remote controllers. So we have D as the correct answer. Question 15 says the diagram below shows a coil in a magnetic field connected to a DC supply. So the diagram below shows a coil in a magnetic field connected to a DC supply. So there we have the diagram. We've got RT, which are going to the DC supply, and we've got North Pole, we've got the South Pole, we've got current that's moving there, and that's the coil, and that's a magnet, As the current I flows in the coil, in which direction will the coil rotate, and what must be connected to parts R and T? In which direction will the coil rotate, and what must be connected to parts R and T? So as long as the North Pole is this side, the South Pole is this side, and the current is going in this direction, what we're going to have is an anti-clockwise direction, meaning an anti-clockwise rotation, meaning this coil will be moving in that direction, to be rotating anti-clockwise. If we had the north and this side and the south that side, and the current in the other direction, would have a clockwise direction, but in this case would have an anti-clockwise direction towards the north. You can see that because it will be moving like that towards the north, and to be rotating like that. And what do we have? Do we have slip rings, or do we have split rings? So in DC connections we have split ring commutators. We do not have slip rings, but we have split ring commutators. So therefore the correct answer is C. We can move on to question number 16. Question 16 says the diagram below illustrates what happens when metal balls H, J, and K are suspended by insulating threads and are brought closer to each other. So we have metal balls H, J, K, J. If the charge on H is positive, what charges are on the ball J and K? So H is positive, J is attracted to H. So if this is attracted to that one, it means opposites attract. So this means this is the opposite, which is negative. And we know that J is negative, so put a negative sign there. And these two are not attracted to each other. So if they are not attracted to each other, similar charges repel each other, so we'd have a negative there as well. So if the charge on H is positive, what charges are on J and K? So J is negative, K is negative. So the correct answer on question number 16 is B. Question number 17. Question 17 says two resistors are connected in a circuit as shown in the diagram below. We've got that, 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 we've got that. So these are ammeters, these are resistors. That is a cell or a series or a group of cells. Which labeled ammeter has the highest current reading? Which labeled ammeter has the highest current reading? So we know that voltage is equal to current times resistance, right? And so current equals voltage over resistance. So the one with the highest resistance will give us the lowest current reading, and the one with the lowest resistance will give us the highest current reading. So if this is 10, and let's assume this is 10 as well, right? This one will have, and let's assume to say this is 2 volts, would have, for this one would have current equals voltage, which is 2 over 10. This is for this one, which would give us 0.2. For this one would have the same, which is 0.2. For this one would have the same as well, which is 0.2. And for this one would have current is equal to voltage over resistance. For the resistance, we'll have 10 multiplied by 10 over 10 plus 10. And this will give us 100 over 20. 20 over 100 will give us 0, 0, to give us 5. And so therefore we'll have current is equal to 2 over 5, which will simply give us 5 into 2, 0.5 into 20 is 0.4. So this one will give us the highest reading. So this ammeter Z will give us the highest reading. Why? Because these two are taking this as the total resistance, but then for this one it's taking these two as the total resistance, and since they're in parallel, the total resistance offered by these two will be less compared to them individually. If these two were in a series connection, the case would be totally different. So therefore, the one that would give us the highest current reading is this ammeter there, which is Z, and is option D on our answers. Question number 18 says, what is the cost of running a 100 watts lamp for 30 minutes if electrical energy costs 10 kwacha per unit? So firstly, 100 watts and 10 kwacha per unit. What else are we given? 30 minutes. So energy or power is given as power kilowatts per hour. That is how much power you be kilowatt hour. So firstly, we need to find this this power in terms of so I was saying we need to convert these 100 watts to kilowatts. So how do you convert 100 watts to kilowatts? So we're simply going to say 100 divided by 1000, and this gives us 0.1. So this 100 watts is simply equal to 0.1 kilowatts, right? And this 30 minutes is equal to how many hours? How many hours are in 30 minutes? We've got half an hour, which is 0.5. And we would say, we are simply going to say 0.5 multiplied by 0.1. So this will give us 0.5 multiplied by 0.1, and that gives us 0.05. So power equals 0.05 kilowatts hour, right? But then we're given the total costs, the energy costs, and it is 10 kwacha per unit. So this is the cost of 1 unit, and to find the cost in terms of this given value, would say multiplied by 10 kwacha. So this multiplied by 10 will give us 0.5. So 0.5 kwacha. So we'd have our final answer being 0.5 kwacha, which is option B. We can move on to question number 19. Question 19 says the following cannot be used in detecting alpha particles, beta particles, and gamma rays. We've got photographic film, we've got diffusion cloud chamber, we've got Geiger-Müller tube or GM tube, and we've got the spark counter. So the question is very particular. It is asking us to identify which one of the above given options cannot be used to detect beta particles and gamma rays. So meaning there has to be one, either one or two or three or four of them that cannot be used to detect beta and gamma rays, but only alpha particles. So when we look at the photographic memory, the diffusion cloud chamber, the GM tube, and the spark counter, the spark counter can be used for all four of them, for all three of them. Don't know why I said four. The spark counter can be used to identify alpha particles, beta particles, and gamma rays. The GM tube, the Geiger-Müller tube, can be used as well. Sorry, I was thinking of the photographic film. The photographic film can be used for all three of them. This one can be used, whilst the spark counter cannot be used for beta particles. So, but can be used for gamma rays, but not beta particles. So therefore, the correct answer is the spark counter, which is A. Question number 20 says, a radioactive source which has a half-life of 1 hour gives a count rate of 100 counts per second at the start of an experiment and 25 counts per second at the end of an experiment. How long in hours did the experiment take? So we are given the half-life of 1 hour. So half-life equal to 1 hour, right? And it starts with 100 counts. So let's say start. And ends with 25 counts. So at the beginning it had 100 counts. Then after 1 hour, these counts dropped to, what is half of 100? 50. I've written 500. 50. After another hour, these counts dropped to 25, and that is where we ended. That is where we've been taught to say it ended. So how long has it taken for these counts to drop to 25? It has taken 2 hours. This 1 hour there and that 1 hour there, and therefore it has taken 2 hours, which is option B. And therefore, friends, this is where we come to the end of this video. Thank you very much for watching. I hope it's been helpful. Remember to subscribe to our channel and download the eSchool app. And if you have any questions, please leave them in the comments, or better yet, you can leave them in our, you can post them on the eSchool social platform, where we'll be able to respond and we'll be able to help you where you are behind. So thank you very much, and see you in the next video, where we'll be looking at section B, and then later on we'll be looking at section C. So thank you, and God bless you.